Welcome. In this video, we will demonstrate the procedure of identifying and treating symmetric parts with the use of the new Detect Symmetric Parts tool. There are many cases, especially in the automotive industry, where symmetric or almost symmetric parts exist at the left and right side of the model. This tool brings the ability to recognize and treat them. This way you can work on one side of the model and pass the results effortlessly and automatically to the other side, thus reducing the model preparation time. Let's begin. Firstly, we need to identify the symmetric parts. Open the model browser and from the Utilities menu click Detect Symmetric Parts and then All. The window that opens contains the parameters which control the outcome of the detection process. In this example, we'll keep the default values. The parts are now drawn based on their recognized symmetry type, a new attribute that has been introduced in ANSYS version 25. The parts are categorized as fully symmetric, partially symmetric, non-symmetric, and parts that are on the symmetry plane. In this model, you can see that most parts are symmetric. Some partially symmetric and non-symmetric parts also exist, as well as a single part lying along the width of the assembly. Working on the one side of the model will save a significant amount of time. In the model browser, activate the Symmetry Type column. Filter the symmetric parts and right-click on them. From the Context menu, select Action Symmetry and then Create Instances. Now the symmetric parts are instantiated, sharing the same name and module ID. Modifications on one part can be synced to the other if desired. To continue, mesh the whole model using Batch Mesh. Batch Mesh utilizes the instantiated parts by meshing only one of them and syncing the other. We can check that by placing two parts on top of each other in wire view. Isolate the two front rails, deactivate the shadows flag, and switch to the side view. Moving along the part, you will see that their mesh is identical. Use Direct Edit Mesh to move a node and reveal the mesh of the part behind. Now we shall see how multi-instantiated parts can be treated. Isolate the right rail and open the Feature Manager. Select all the holes, right-click on them and select Mesh Treatment and then New. In the Treatment window, activate the zones and define two zones of width 3. Apply the treatment and proceed with the reconstruction of the mesh. You can see that the zones have been created. Bring its symmetric part to visible via the Select Symmetric option in the model browser. This part does not have zones. If they are required, there is no need to create them from start. Just select the modified part in the model browser and from the Context menu click DM and then Sync Representation. The left rail has been updated. This applies to any modifications existing on one side. Let's continue to the treatment of partially symmetric parts. According to our recognition settings, these parts are 60 to 90% similar. Isolate the two legs. Some differences are evident, like the cut and the two holes the left leg has at the front in comparison with the right one. Focus on the right leg. Switch to Feature Draw mode. Activate Direct Edit Geometry and left-click on the hole in the back. In the Treatment window, enable the zones and define a zone with a width of 3. Go to the middle of the part, where a strain gauge will be placed, and create a Mesh Refinement zone. Switch to the Surface Mesh Ribbon tab and activate the Refine Quad Steps function. Select the area to refine and in the settings, choose to create a 1 to 2 smoothed quad mesh with unchecked the Freeze Free Edges option. Click Apply and then Finish. Now that the modifications have been made, we can check and exploit the similarities between the two parts. Right-click on the modified part in the model browser and select Action Symmetry, and then Inspect. The two legs are shown side by side with their differences highlighted. Change the layout to view them on top of each other and have a closer look to their differences. Besides the cut, the left leg has 3 holes in the bottom flange instead of 1 and a narrower top flange. As the modifications exist only in the right leg, click the Apply Similarities/Differences button and choose to copy the similar faces in order to pass the modifications to the left leg. A report window opens which shows the areas that have been changed. Both sides now have an area with refined mesh and a washer around the back hole. Alternatively, you have the option to copy the different faces in case of a wrong or not updated design. In conclusion, the new Detect Symmetric Parts tool reduces significantly the pre-processing time by identifying symmetric and partially symmetric parts. Fully symmetric parts can be instantiated and information can be synced from one side to the other, while partially symmetric parts can be inspected and their common or different areas can be copied from one to the other. Thank you for watching.